Hello and welcome to the latest Manufacturing Management Live panel. My name is Chris Beck. I'm the editor of Manufacturing Management, and today we're going to be exploring the increasingly popular technology of additive manufacturing, 3D printing. For many within the mainstream audience, COVID-19, the events of the last year have perhaps been 3D printing's watershed moment. The technology has come to the fore to address supply chain issues that have hampered the provision of vital PPE and medical equipment across the world. Now, at the same time, manufacturers, large and small, have seen the advantages that the technology can provide in terms of its agility as a strategic tool to help solve supply chain complexities and increase production flexibility during the pandemic. With the ripple effect from supply chain issues that were originally felt early last year still being felt today, and of course the likelihood that Brexit, which isn't going anywhere, is going to be another issue that impacts many manufacturing companies for years to come. We're going to be discussing the opportunities for those companies that are already deploying or thinking of deploying additive manufacturing within their factories. Now, my guests today bring a variety of perspectives to this topic. Each is ready to look at what manufacturers should consider when it comes to effectively deploying additive manufacturing to increase efficiencies throughout the entire workflow from beginning to end, while decreasing the vulnerability of the production chain. First, I'm delighted to welcome Yann Rageul, Head of Manufacturing for Europe, Middle East and Africa at leading global additive manufacturing solutions provider Stratasys.
Thank you, Chris.
He's joined by Carlos Vicker, Chief Commercial Officer at AM Flow, a developer of advanced manufacturing solutions that drive the digitalization and automation of additive manufacturing processes in post-production. Carlos.
Good morning.
And last but not least, I'm delighted to welcome Lee Barth Nelson, co-founder and VP of Business at Israel-based Leo Lane, which via its cloud-based solution helps companies safely use digital inventories and protect their IP by enforcing a consistent, repeatable, secure and trackable digital supply chain for additive manufacturing. Hi, Lee.
Thanks for having me.
Before we get into the kind of guts of this discussion, it's probably a good idea to start with a kind of opening question around the advantage of additive manufacturing. Why should manufacturers be considering it, especially at the moment, and where potentially is a good place for a company to start on their additive manufacturing journey? Yann, I'll come to you first for that.
So I think it's very important when you look at additive manufacturing to start probably with the tooling aspect. I think the technology is very well known for prototyping for many years, but we've come a long way, and now I think most of the OEMs and customers we have actually start their journey with jigs and fixtures and tooling applications before moving into more, I would say, complex end-use part application because you need more certification to be able to achieve the end results. So that would be my first recommendation.
Thanks, Yann. Carlos?
Well, yeah, additive is something that you have to experience. You have to go through the flow and learn what it means to produce something with a new technology. So, we all know it's been used a lot with prototyping, but once you get to know about the functionalities and what AM can deliver in terms of quality, in terms of repeatability, that's when you start with what Jan suggested, jigs and fixtures and tooling and things like that, which then you can implement quick and nice and easy in your environment. But ultimately, additive manufacturing, the intent is that it's going to be a mature manufacturing technology, one of which you can choose between all other existing technologies, and there are steps to get there. So I think it's about experiencing what you can do and what you can't do yet, and going into that learning curve.
Absolutely, and Lee, finally.
Well, I look at it from a slightly different point of view. I look at it from the business point of view of a manufacturing manager. Chris, you said it, if the last year has taught us anything, it's that we're at the mercy of supply chain failures if we continue to use physical supply chains only. And if we want to use digital supply chains, which are much more flexible, nimble, robust, all the nice words, then first of all, they go with additive manufacturing and on-demand manufacturing, and it can allow manufacturing managers to shine in times of emergency while saving overall costs for the organization. The manufacturing itself may not be cheaper, but because you save on the supply chain, overall, the company is saving costs, and the manufacturing manager can actually expand their team and their responsibilities and help out the company, not only day to day, but also in those emergencies where everybody is failing, but they will not.
Thanks, guys. Yann, I'm going to turn to you. I mean, you and Carlos both mentioned there that additive manufacturing is often seen as kind of a prototyping tool, and maybe manufacturers don't consider the other applications. How can additive manufacturing be integrated across the production chain at every stage of the process? Can you maybe give some examples?
Yeah, I think actually that's a really good point. I was thinking about sharing a couple of examples of end customer. I think that's the best way, I think, to prove the point that we've moved into real applications. Especially, I think one of the key topics we see with manufacturer today is metal part replacement. And let me grab two examples here. So this is a company in the UK based in Slough called John Crane, work in the oil and gas and heavy industry. They make typically seals made of steel, so kind of heavy components, mainly used to make part made of metal. So this is a soft jaw made of aluminium, and this is the equivalent made in nylon 12 carbon fiber. So this is actually a 2.3 times lighter than the aluminium equivalent, but because of the 35% carbon fiber, it has in excess of 900 bars in compressive strength. So it's a really impressive material, which provides a lightweight. So in terms of health and safety, if you scale that up to a much larger tool, you have also some benefits from the health and safety example. Another example, which is in this case, I will have to take a step back because it's a very large part. Again, it's about a meter long. It's actually, this tool is used for wipers assembly tool in the automotive industry. Again, this tool is very stiff. So if I try to bend it, I cannot really do anything to it. And this is actually made in nylon 12 carbon fiber, the same material, and again, much lighter. So if you imagine the operator having to take this large tool and then position it onto the vehicle time and time again, at the end of the day, if you're not a bodybuilder, you probably struggle with the workload. So it's a great benefit in terms of the health and safety, the weight saving, but also the cost saving, because we see typically for tooling between 40 and 90% cost saving. And if I take an example in the automotive industry, Opel is saying they reach up to 90% cost saving. So it's actually coming from real example from automotive customer, but not just automotive customer. We work with companies like John Crane or a tool maker called Brown & Holmes in the UK. He's using one of our Fortus 450 printers to make different jigs and fixtures for their customers.
Yeah, thanks, Yann. That's really interesting. It's nice to see some kind of real life examples of how additive manufacturing is making a difference. Carlos, I'll bring you in here. Yann's just spoken about some of the efficiencies that can be seen all the way through from prototyping through to kind of final parts and tooling in between. But there's more that can be done in terms of making workflow even more efficient once parts have been produced. Is this correct? Carlos, you're on mute, I'm afraid.
Much, yeah. Thanks for the reminder. What Yann showed are excellent examples of applications for additive manufacturing where you can automatically see the benefits either in speed or in cost, and there's another element that hasn't been mentioned yet, the full freedom of design that you can apply to additive manufacturing. So you're no longer in a stronghold of the limitations of existing manufacturing technology. Additive manufacturing enables full freedom of design, and therefore you can get much more sort of organic kind of designs. Now, so once an environment starts using additive manufacturing and going through that learning curve, as I said earlier on, and finding applications, just like Yann showed, ultimately you get to a point where you're no longer just testing stuff, but you're making those parts and using those parts. So basically you are already manufacturing parts with additive manufacturing. Now, once you get into that situation, and the best example is service providers, where you can just upload your design file and they print it for you and send it back. Those guys, they've got thousands of clients, all individuals asking for a particular part to be printed. And the whole economy of sort of printing is about getting as much printed in one print batch in one go, and then processing it through your system. And so there are different ways in which efficiencies can be created if you start thinking from, and I'm going to put it as a phrase here, a additive manufacturing production line. So that's a huge step away from just prototyping and making a few pieces, but thinking about, I want to make a full line in which I can then design digitally, I'm manufacturing digitally, and then you get the post-processing. And that post-processing, a lot of that activity is not just about, it's about if you take SLS or MJF, those are the two largest groups of plastics in additive manufacturing. You've got depowdering, cleaning of the parts, etc. And then you've got a crucial part, which is called basically, how do I identify a part just based on its geometry? I've got no tag. It's just an object of plastic, and it comes out of a printer. Who's the client behind this? What has to happen to it? Do I need to polish it? Do I need to dye it, etc., etc.? So in those service provider environments where there's a high mix of all sorts of parts, they literally end up with hundreds of parts on a table trying to shift out what's what. And the efficiency that you just referred to, Chris, is basically we can automate also all those steps after that printing and cleaning, and therefore make it a complete end-to-end digital environment. And I think the mere fact that we've got the situation now where people are helping out with identifying and sorting stuff is completely in contrast with the whole intent of additive manufacturing. You want it to be digital, and you want that manual labor to be taken out. And with my background from a service provider perspective, we increased the number of printers up front to produce more, and we had to recruit a lot more people at the back end to help with actually all that processing. And purely from a business perspective, that's not scalable. Again, we're talking about efficiencies that we're trying to achieve, and it's cost efficiency, it's time efficiency, it is material efficiency. There are all sorts of elements that additive manufacturing can contribute in that area. And we are these are the very early baby steps in that area towards what we call an additive manufacturing production line, which is end-to-end digital. But that is the way the industry is thinking. So, for the listeners of for this podcast, it's understanding that, the whole industry is evolving further and further with great materials. Yann referred to specific materials. We're finding new material and printer combinations which enable even more different kind of applications. And this is just going to grow and grow. And I believe companies just need to look at, okay, how can I make this relevant for my environment, for the way I work, for the kind of solutions that I'm looking for and the applications that I need, and then start trying out how to move forward in that area. Again, it's an evolving market and very exciting one at that.
Absolutely, yeah. Thanks, Carlos. Lee, I'll bring you in here finally for the kind of final step of the process. So, how about when it comes to keeping track of complex production needs, simplifying that process, and things around ensuring certification? There's a lot of standards involved in manufacturing. So how can companies make sure that they adhere to any standards, especially when producing more than one kind of part using additive manufacturing?
Yeah, that's actually a really important challenge for additive manufacturing, because as we all know, manufacturing is often certified, whether internally or externally. And normally you certify the manufacturing line. And then it churns out whatever it's churning out. And once in a while, the certifying body does a spot check and it comes back maybe after a year to certify it again. But in additive, inherently, as Carlos said, it's varied. It's a batch size of 1 potentially, or 2, or 10, or 10,000, but certainly not millions. And what are you certifying? Because the part you printed yesterday may have different settings than the part you're printing today. And then when you come back to yesterday's part, how do we know that you actually changed the settings back? And how can you prove to the certifying body that that actually happened? And that's why you need a tracking mechanism on the printing, and also an enforcement mechanism that'll make sure that you're printing it correctly according to the certification every single time, so there isn't a human error element to it, or any other kind of error, especially if you're printing it in multiple locations, and as Carlos said, potentially with multiple providers, and maybe in different printers. And I'm sure Yann can tell you that in different places, sometimes the printers need different settings to achieve the same result, because it's different climate, or it's a different model of a printer, for example, even though it's all Stratasys Fortis, but there are different Fortises. So all of this is required for certification. And that's what we specialize at Leo Lane. Besides offering IP protection, we also offer this enforcement, so that every single time a part or a jig or a fixture is printed, the result will be the same, and everything that the designer of the part wants to happen will actually happen. And now with that, and with the tracking that we provide ex post, like an audit trail, you can certify, and you can prove automatically even to a certifying body that you've upheld the certification every single part.
I could just add to that one. I just referred to all the parts in the post-processing. Lee and her company come up with solutions that run up to the point of printing. After that printing, even then you need to keep track and trace of what is being printed. And that's where our company comes in, AM Flow. So once we are able to identify parts on geometry, we can actually understand where each individual part is in a factory, and which post-processing activity has been done, when it's been done, with which machine, and we feed back all that data into the ERP, and connecting also with the security aspects that Lee just brought up, so that you have a digital thread of manufacturing. And that is a requirement for things like certification. We have to prove the industry that we can come up with really repeatable, efficient, high volume potentially processes that we can then certify and show each step that it is consistent in that sense. So, and that's the beauty of a digital environment. This is all very much possible, and it's all happening now.
Absolutely, and all of that while maintaining the variability and the wonderful properties of additive manufacturing that allows you to switch and be super efficient. And so that really requires a lot of automation. And as Carlos said, if you integrate our systems with theirs, you can really get an end-to-end secured and consistent, repeatable solution.
Yeah, so the interesting thing here is that you might be asking, are we talking just about a production technology, or are we actually talking about a manufacturing strategy? Because there are so many pluses and benefits to be gained with additive manufacturing. And of course, it's a learning curve and it will take time. But once you start learning how to get the best out of that still evolving technology, it's not that we're static, it's still very much evolving. It's got a long way to go. But there is here the potential of actually looking at additive manufacturing as one, maybe not the only one, but one of those manufacturing technologies that you can then put into your strategy for flexibility, efficiency, quickness, for great design, you name it.
Yeah,
I think,
thanks. Sorry, yeah.
I was just going to add, I think it's a very interesting line of conversation. So I think it's very important, I think, to have, the entire flow. I fully agree, post-processing. I think one of the things we also offer is a connectivity on our printer as well. So, the printer as well can be integrated into, for instance, your PLM software through, MT Connect, but also through a dedicated API. So we fully agree on that side that, the connectivity, the data management as part of the ERP system or the MES software, which are familiar with the manufacturing managers typically, is critical, and that's really important to consider the full integration from the part printing, the post processing. How do you secure all your information as well? So I'm glad we have common topic here with the other speakers.
Yeah, I think it's super important that Stratasys and other printer manufacturers are offering these APIs, because without that, none of what we were doing would be end to end. You have to communicate with the printer, and I think it's amazing. These APIs are, I know some of them, they're really important for what Yann is saying. Being able to control the machine, to communicate with it, to understand what it did. And we all know how important it is to do that remotely after the year that we've had. You can't always count on somebody being right there at any day that you want. And if you have that connectivity, that's a really, really big plus. And unfortunately, not all printer providers have done this yet, but I'm hopeful that this will be something that the current ones are leading the way, and it will expand, because integration, as you see from this discussion, is super important. AM is a relatively fragmented industry, and you really want to have an end-to-end solution, and the way to get it is through integration and software.
Just to pick up on that, Lee, you talked about additive manufacturing being fragmented. Do you think that's part of the reason that until recently, as I mentioned earlier, for various reasons, additive manufacturing has really kind of become more of a mainstream idea within manufacturing? Do you think maybe that fragmentation is part of the reason why uptake has been maybe slower than people expected back a few years ago, when the hype was really beginning to grow around the technology?
I think that the fragmentation makes it hard to put together an end-to-end solution. And even, it's important when you start off on a trip like this, like additive manufacturing, to have a quick win and to have many, many quick wins. You have to keep the goal in mind and build towards it, but you also need to get quick wins. And a lot of expertise was needed. And I think that everybody in the ecosystem made a concerted effort to make it more accessible and to integrate, which makes it more seamless and easier to implement. And as Carlos said, there are service providers and there are turnkey solution providers that can offer you your first dip into the technology without having to gain all of this expertise on your own, which is really, can be daunting. Even if it's not really as difficult as people think, it's daunting to think about it. You think about the materials, you think about the machines, you think about designing for 3D printing. It can seem daunting. And then if you do start and it seems daunting to you, you can always go to a turnkey provider or to a service provider that's advanced and that knows your industry, and they can help you along. And I think that those are things, they've always existed to some extent, because Shapeways, Carlos can tell you, has been around for a long time now. But I think that this kind of thinking that is more production, more repeatable, more manufacturing has evolved over the years, and it comes together with the integration, which I know that customers are very thankful for.
Yeah, I think just on fragmentation, if I could add a point there, the fragmentation is actually a result of a growing market, right? It's everybody wants part of that pie, and there are more players coming to this market. If you just see the increase, for instance, in the number of OEMs with FDM printers, it's gone through the roof. It's skyrocketed. So there are much more players coming on. So there's a reason why it's fragmented. And I think I'd like to give a bit of a history here, because the part past 30 years, basically, we've been investing a lot in printer technology so that the printer, the core, basically can show what it's actually what it can deliver on, and improving the quality of the output, improving efficiencies. 30 years, big investments in those areas. At the same time, we've also invested in materials because we had to come up with the right materials for those printers, the combination of the actual technology with a type of material that is what is going to define quality and application possibility. And then the third area where we've been investing in a lot is in software, not necessarily the area that Lee's active in at the moment, but a lot of it about design software, all right, CAD/CAM and that kind of stuff, and ERP systems and nesting systems, and all that there's been huge investments over 30 years. It's only just now where the part where my business currently is active in, that there are investments made in post-processing. It's only now just started. So I just want to share with the audience that these are all evolutionary steps. The fragmentation is actually, yes, it does make life a bit difficult, but at the same time, it's part of our own success. It is part of the journey that we have as an additive manufacturing industry. And we're still going to see quite a bit more of that fragmentation. But in the meantime, we're also seeing market movements with takeovers, M&As. So we're also seeing the reverse activity where basically groups of activities are brought together at one point. We're going to see a lot of this movement in the market in the coming 5 to 10 years, and that may also be potentially daunting for the audience. But what I'm trying to tell you is that, hey, we're all busy learning and making it happen, and join the game, so to speak. And there are different ways of going into that learning curve and understanding how you can apply it in your environment.
If I can add a bit on that, I think maybe I can take a couple of examples of things which are already happening today. I've got an example from a company, John Crane, I mentioned them earlier. This is actually a part which is a spare part. So you can see it's actually with an impeller in the middle. It's used as a spare part. And this actually was 98% saving. We cannot disclose the exact figure, but I can tell you it's a very high number in terms of cost saving. Also, what was amazing is they were able to combine 20 parts into a single one. So just an example of things happening today and taking benefit of the AM. Let me take a step back. I've got a part behind me, which is this part from Siemens Mobility. So Siemens Mobility today on their website is doing this example. So here, normally, you would have a USB charging point, and this part here would be fitted vertical like this onto the kind of a bar that you use to hold into the bus or the tramway. So it's a certified fire, smoke, and toxicity rated part, which is a real land use part. Obviously, this is straight from the printer. It will be painted in whichever color you want. But today you can go onto Siemens Mobility website and actually look for additive manufactured part. And with Stratasys printer, they're actually creating on-demand parts. They talk about 95% lead time saving. There's also a cost saving, but obviously it depends on the part, so they don't share this. But it's clearly cost and significantly time saving. The additional benefit is as well, they don't need to hold any spare parts. They are actually producing the part on demand. As soon as the customer click on the part, the printing process starts. A couple of days later, the part is received by the end customer. So this is a fantastic, very agile model. Obviously, we are not talking about, as Lee mentioned, 1 million parts. We're talking about, a few hundred parts. But there's definitely technology where we can, and for some parts where we can go even higher. We talk about, maybe 50,000, maybe 100,000 parts can be achieved depending on the geometry, the complexity of the part. But at this example here, we took, in the tens or hundreds of parts, no more.
Yeah, and that's a very special material as well, right? Because
yes.
it's fire retardant, isn't it?
Correct. So it's actually Ultem 9085, which is a material which doesn't propagate fire, emit very low amount of toxic gas as well, doesn't drip. So if you compare this material versus an ABS and you light a fire, one of them would drip, propagate the fire, and leave you very little time to escape from the burning bus or tramway or train. So it's not really the type of this is a great material because it doesn't really propagate the fire.
And that's
No,
super
but
important for certification.
Of course.
Exactly. I think
yeah.
Go ahead. Sorry.
Well, another point, that 95% lead time. I mean, just imagine what that could do to your innovation cycles. If our audience, if they understand what innovation could do for their business and how innovation is actually the way forward to be competitive, to create your own niche, to et cetera. Innovation in itself, with these kind of technologies, materials, you can speed all that cycle up and you can be much quicker in the market with your innovation. Just imagine what that would do to the business in that sense. So, lead time, great number of reduction, lead time reduction. Eventually, we're going to work a lot on cost price reductions also. It's production on demand. There are so many, I believe this coming 5 to 10 years, the real benefits of additive manufacturing, that when the hype was really on its highest, we were all talking about the real benefits, that is now going to come through because it is a system that is starting to be built. And it's not just about the printer, it's not just about materials, it's not just about software or post-production. It is, and Lee already said it, sorry I'm repeating there, Lee, but it's that integrated approach.
Yeah, and I think we don't need to wait 5 to 10 years to see the benefits.
Oh, good, even better.
The last year has shown so many people a lot of the benefits that we would have worked 5 to 10 years to convince them that they're out there. There are silver linings to disasters. I kind of feel bad saying that because it is a disaster, but the silver lining is that, we don't have to say much. It's proven itself. And I think that you don't need to wait in order to realize the benefits. And if you think about it, it's not just about your day-to-day supply chain going digital. It's also about creating an alternative supply chain. The companies that thrived in the last year found alternative ways to get over the failures, but they found them on the fly and they weren't always optimal and it was problematic and costly. If you think about it in advance, and we all know that there will be more failures. I don't think there's anybody who thinks otherwise after the year that we've had. So you need to prepare for that. And by putting in a digital supply chain with additive manufacturing for some of your parts where it makes sense on a day-to-day basis, you're also laying the groundwork for an emergency case where you have a failure where you didn't plan it. But if you've prepared the groundwork in advance, you can switch over almost seamlessly and take advantage of it. And you can do that now, not 5 to 10 years from now,
That's right.
today. And I think that that's the key, because it really is a big, and in those situations, the cost savings are through the roof because the alternative is super expensive. I mean, I know that even before COVID, when there were trade wars with China, between the US and China, some people sent their employees with a suitcase to China to bring a spare part in their suitcase. You can imagine how much that ended up costing. And, when COVID's around, you can't even do that. So if you have a credible, reliable, repeatable, correct way of doing this and protecting your digital assets, everybody knows there was a very famous story about ventilator parts in the beginning of COVID in Italy. And the ventilator company was ill prepared. So people reverse engineered these parts. And these are the consumables. This is the main business of the company. So they couldn't give out their 3D models unprotected and unprepared. But had they prepared, they would have been the saviors. They would have had customer loyalty and they would have made a lot of money. So
I completely
it's
agree.
worth remembering that.
many of our customers actually with our system during the pandemic were really quick at making parts for the NHS for ventilators. So they actually, many of our UK created consortium cross industries from automotive to aerospace working together on developing the ventilators and printing parts and prototype functional parts and things which were actually used with patients. So it was fantastic reaction, and I think it opened the eye of many of people who don't have a 3D printer that actually they missed out, and we saw actually some of our customers supplying parts for other company who didn't have the 3D printer. So that was a fantastic reaction.
Yeah.
Yes, I think eyes have been opened by, like Yann was saying, and indeed Lee was saying, some of the applications in the past year or so with ventilator parts and other bits of PPE being 3D printed. But how do companies now might have invested in a 3D printer to help make ventilator parts? They might have had additive manufacturing capabilities beforehand. They might be thinking, oh, we didn't get involved in making ventilators, so what's the point now in investing in additive manufacturing? We've touched a little bit on the kind of pressure that supply chains are under, whether that's trade wars, the pandemic, things like Brexit, making manufacturers look at where they source their parts from, and the role that additive manufacturing can play in bringing some of that in house and kind of mitigating some of the risk. But what are the other, if you're particularly for smaller companies, Yann, you've shown examples from companies like Siemens there, but for smaller companies, why should they be considering additive manufacturing as something to explore, especially at the moment when financially times are a little bit tough?
I think typically when we work with customer, and I'm mentioning Siemens because it's a brand name that everybody can recognize, but Brown and Home is more type of SME really. We have many customers who today are using a technology who are not as well known and are actually having cost saving which are very significant for their business. We always do a return on investment with the data from the customer. So, we took their part CAD file, we simulate the cost of the part, and we can help them doing their ROI. And very quickly, they're able to see, okay, this printer payback, is 9 months or 18 months. Or, typically we get fantastic return on investment from, as long as you can find a couple of applications, especially around jigs and fixtures. If you find spare parts, it's even bigger saving. I can mention, for instance, the Schneider Electric in Spain. They say that investing with one of our printer, they were saving about 20,000 euros in this case, per year. And it's just a small example. We have many companies like that who are doing huge saving. I can show you an example, another part, which is actually from a chocolate factory, and this is actually, they had this part which move chocolate bars. There's another part missing here, but you can imagine it's doing this action all the time. It was an aluminium component, and they were able to print this part in under 50 minutes. And that is the cost benefit and the time benefit. So they had a problem, the line stops, which cost huge amount of backlog and cost, and the cost of the part becomes completely irrelevant. Even the cost of the printer can be wiped out in just one single failure. So if you're an OEM and you know that you have problem and you don't have parts to fix your problem, then I would really strongly recommend looking at 3D printing, because you will have a solution that can provide you, within hours, a solution to a factory issue that make you to days or maybe even weeks to fix. And even if it's a temporary solution, an example is a gear on a lace which was printed, functional part, replacing an aluminum gear. And this was able to take the load on this component. And able to, you can start, resume your production, generate profit again, and then maybe find a part which is more longer term, if needed.
Yeah,
So
we
that's
call
what
those emergency spare parts. It's like the spare tire in your car, which may not be the same quality as your regular tire, but it's good enough to get you until you get a regular tire.
Yeah.
And I think that that's another case for, manufacturing managers. I don't need to tell you, the main thing is to keep the line running. If the line stops, there's an enormous cost. And if it's because of a jig or because of a spare part, and you can get that digitally, immediately printed and onto the machine within an hour or two, that is an enormous improvement, even if it is, as Yann said, an emergency spare part, which afterwards you're going to replace with the aluminum part that'll arrive in 2 to 6 weeks, which is great. But you didn't have to wait for 2 weeks for it and accrue losses.
And in all honesty, Lee, there are companies now that apply it and then find out, wait a minute, this part is actually quite good and I don't need it I don't need that replacement yet. I can go a long way with what I've got at the moment. So I don't want the audience to think that, AM is just about that replacement part. No, some of these parts are really strong and durable and match the requirements of what you're looking for. So I think it's about the flexibility. We're talking about flexibility in that sense for, the manufacturing environment that is dealing with basically the vulnerabilities in the market, COVID, Brexit, maybe, geopolitical aspects. So, the future is unpredictable. You need to have that flexibility in many different ways as a company. And additive manufacturing is a potential source of that flexibility to deal with, changing situations, and you need to react quickly. And then additive manufacturing is one of those solutions that you can actually apply. So again, it's a broad set of benefits that you can actually address, and get out of additive manufacturing. And I think that's a very important one for our audience.
Yeah, Carlos, very good point. Actually, this part here I was showing was a permanent replacement part.
There you go. Yeah.
The gear wasn't, but this one was definitely actually exceeding the aluminum component. They were actually had better because they were able to design in such a way they were able to improve on the actual aluminum part.
Yes, in talking with some service providers, I spoke to one who was dealing with an automotive client, and they were producing prototypes for that client. Then the client said, well, these prototypes are so good, can you produce a couple of hundred? They are now producing a couple of thousands of that same part. And so they don't switch back to the original technology or the original material. Additive manufacturing has come up with a solution that is permanent. And we're seeing serial production also stepping into the business-to-business environment. So it's, again, flexibility, yes, but it's also you can actually produce final end-use stuff which has great quality.
And even sometimes better, like Yann showed that windshield thing. It's ergonomically better because it's lighter. Yeah. And the assembly worker has to carry that around, and a lot of times ergonomically you can customize something for whatever the application is, and that can be a huge benefit. So there are so many benefits, and as Carlos said, once you start, it's easy to find the additional ones. And I agree with what Yann started with, which is it's easiest to start with jigs and fixtures on the manufacturing line, because that's something that's completely within your control, and you see the results yourself, and you can see how the parts hold. It gives you a quick win, which is always good. It keeps your line up faster and less downtime, which is a great win. But you also can see with your own eyes what it can do, and then expanding that into spare parts, emergency spare parts, and all of these lovely things is an easier step than jumping over there immediately.
Absolutely, yeah. Just to kind of begin to wrap up, we've touched on a lot here, and Carlos and Lee, you've already touched on what the future has in store. Carlos was looking 5 to 10 years in the future. Lee said it might be even sooner than that. But if we all get our crystal balls out, what is the kind of potential for additive manufacturing compared to where we are now? And obviously the pandemic has accelerated quite a bit of uptake and demonstrating the capabilities. But what are the possibilities for additive manufacturing into the future? Yann, if you want to start with that.
I think one of the key trends we see is obviously, we work with Airbus, we work with Siemens Mobility, already unused parts, spare parts, within aerospace, automotive. transportation. We see it more moving into the SMEs, right now. I think the what we're offering, is quite unique in terms of the level of repeatability and accuracy within their system, but also we are also increasing the volume. So it's a shift from, the quite holistic, the top of the big OEM only being able to afford 3D printing to now having system and return on investment, which really makes sense for the medium enterprise really to make an investment. And also the volume moving from tens to hundreds to thousands to even tens of thousands now, with new technology and processes. And it was mentioned about acquisition. We actually also are acquiring new technology to be able to cover, because with additive manufacturing, there's not one single technology which cover all the full spectrum of application today. You need, each of them will have different benefits. So we have broadened our portfolio to be able to offer our customers even, different applications. So we see really the shift from, not being so affordable to be more affordable for the mass market. And also the volume going up. This is really a key trend, but also in terms of innovation on the material side, and certified process, in terms of repeatability, and a complete solution as well. People want, what we discussed earlier is they don't want just a printer, they want the full solution with the post-processing, with the software, and that is definitely the trend, moving forward. But I would say, for me, it's not the future. It's happening now. 2021 is actually a cornerstone of big changes within the industry, acceleration in terms of the volume. And I think 2022 is going to be a really explosion in terms of number of people adopting the technology.
Thank you. Yeah, and Carlos, is there anything you'd like to add to that?
I'm all in favor of reducing that timeline from 5 to 10 to 1 to 2 years. So don't get me wrong there. So yeah, I know I'd love to see it explode. I think what's happening is that more and more companies are finding those applications that are relevant for them, that make that have got a business case underlying it and supporting it, so that it makes business sense. I think that's the most important aspect as well. Don't forget that all our listeners are part of companies, and they're all businesses, and they need to produce stuff that sells. It has to be relevant to the customers, and they have to adopt changes, etc., etc. Additive manufacturing has all sorts of benefits that support those activities. So once environments, production environments start finding where it's useful for them, I do see a potential explosion. It will be great to see that paradigm shift. But in the meantime, we're as a production technology, we're at best 1% maybe of the full pie of manufacturing technology market. All right, we're nowhere near yet substantially out there. So there's still a lot of market to gain, a lot of opportunity, and I completely agree. If we can get to a fully integrated approach, that's when you're going to see even another step change and another uplift in the market. Instead of individual areas and workstations performing great, it's going to be a full line, and that's when you're going to see real changes happening. That's what I think is going to happen, and again, hopefully within 5 years.
Thanks, Carlos. And finally to Lee.
I think that if we look forward, manufacturing technology, additive manufacturing, is just another manufacturing technology. And that's where we want to be. I always tell people that my aim is for it to be boring. You don't ask who did the handle on your nightlight. You don't care. So I'm looking forward to the day when you don't say, oh, look, I have a 3D printed part. It's just going to be another boring manufacturing technology. I don't think it will replace injection molding or any of the other technologies that are widely used now. I think it would be an additional manufacturing technology. And I think that the great benefit is what we talked about, the robustness, the flexibility, the digital supply chains, if you do them well and secure them. All of that, if you do that, you have a tool in your toolbox that when you need, you can bring it out for the right application. And I think Carlos is right. We haven't reached the potential in terms of the percentage of the manufacturing industry. I think 1% would be great. You know, it's a $16 trillion market. I don't think we're at 1% yet, but we're working on it. So I think it can definitely grow a lot. And I think that forward thinking manufacturing managers will want to have the capabilities and have at least some of their products manufactured this way so that when additional ones come in, they can offer this kind of technology as well.
I would add that, you know, a message to people doing injection molding and CNC machining. We are not the enemy, actually.
Exactly.
We are very complementary. You know, many of our customers are injection molding specialists, and they see our technology as very complementary. We also, you know, some of our customers print fixtures for CNC machining, for instance. You know, you don't really want to machine a fixture to machine your part, because it's actually a wasted time of your asset, which is your CNC machine, and you would rather dedicate it to produce the end-use part. So you can run the 3D printer to make the fixture and then do the end-use part. Let's say if it needs to be in steel, you know, machined out of aluminum or steel, and it does make perfect sense. So we're not saying we're going to replace everything. I think Lee was completely right. We see ourselves as being a complementary technology, and so don't be scared and go ahead and talk to us.
I think the two keywords from this entire discussion, well, three keywords to this entire discussion is complementary, integrated, and digital.
There you go. What a lovely way to end. Thank you to Yann, Lee, and Carlos. We've covered a lot in the past 50 minutes or so. You know, talking about efficiency and the cost benefits of it. Yann showed some very interesting examples, real life examples that Stratasys have worked with. We've talked about supply chain resilience in the face of the pandemic and Brexit and other kind of global disruptions, and how manufacturers can mitigate some of the risk from that. We've talked about you know, lead time saving and the need to not have to store lots of spare parts just in case. Even, you know, produce 3D printing parts that will you know, last the same length of time, if not more time, than original parts. We've talked about the future. Lee and Yann both said the future is here now, and 2021 is set to be a big watershed year for additive manufacturing. So now really is the time for manufacturers of all sizes to start embracing the technology. Thank you to Yann, to Lee, and to Carlos again for your time today. Thank you to anyone who's watched this. If you want to get in touch, either with myself or any of the panelists to raise a question or raise any points, then please do email me at chris.beck@markallengroup.com, and I'll pass on your thoughts and your questions to the panelists. And thank you all for watching, and thank you again for your time. Thank you very much.
Thank you, Chris, and
Thank you. It was great. Thanks.
Thank you.